special number sets. Here we're going to discuss several number sets, and there is a history to them, so it's quite interesting to look at this. The most basic set of numbers is the natural numbers, given this symbol here with a double-barred n. The natural numbers, or counting numbers, start at 1 and go up in ones, essentially forever. Historically, this was the first set of numbers, and I'm not sure that we can even say when people started counting with these numbers. It's probably prehistoric. The next set of numbers, and the way that this is indicated going around, means that this set Z, which is called the integers, contains all of the natural numbers, but it also contains some other numbers as well. For example, 0 and -5 are integers, but they aren't natural numbers. So the set Z of integers contains all of the natural numbers, 0, and all of the negative whole numbers. The next set that contains everything in Z and more is the set Q, the set of rational numbers. Fractions historically come along much later. So in here we have things like a half and -13/5. But note that 2, for example, is also a fraction because you can express it as 2/1. Then we have numbers that cannot be expressed as fractions. That leads us to the set of real numbers. So everything inside is a real number. Half is a real number, 0 is a real number, 3 is a real number. But then we also have numbers which cannot be expressed as fractions, such as pi, or e, or the square root of 2. Now there's just one more number set that contains all of these, and it's not one that you particularly need to know at this level of maths, but that's the set of complex numbers. Contains all of the other sets, and as far as we're aware, it's the last set of numbers. These have been around for about 350 or so years. And in here is I, which is the square root of -1. All the real numbers are part of it, and we also have numbers like 3 plus 4i, which is a part real and part imaginary number. Commonly used subsets are things like Z plus, which is just the positive integers. So Z plus is the same as the natural numbers. Z minus, which is just the negative whole numbers. Real plus is all of the reals, and clearly we can't list them as a set. Using some notation we met earlier, we can make statements like 33 is a member of the set of natural numbers. 2 pi is a member of the set of real numbers. 2/3 is a member of the set of rational numbers. And indeed, 7 is a member of the set of real numbers because the real numbers, remember, contains the rational numbers and the integers and the natural numbers. We can also state things like pi does not belong to the rational numbers. We know that pi is a real number that cannot be expressed as a fraction. And -5 does not belong to the natural numbers. The natural numbers, or counting numbers, start at 1 and go up in ones.